This is example 8-1, where we're going to take a set of units and ratios of them, or variables, and we're going to see what their MLT dimensions are. So the first one is Q times P divided by L. So a volumetric discharge times the pressure divided by L length. So we can say that is equal to, now for a volumetric discharge, right, that is volume per time, so L cubed per time, so T to the minus 1, that's Q. Pressure is a force per an area, so if we break that all the way down, we get a mass per length per time squared, right, because it's seconds squared. So that's our Q times P, and then L, of course, is just a length. So then if we write these together, on the top for the first one we have L cubed. We also have a T down there. Then we have M, and then L to the minus 1. And, not minus 1, that's just to the 1 then, of course. And then T to the 2. Let that be up here. And then the only thing left is an L down there. So that is then ML cubed divided by L squared times T to the third. And then lose some of my L's. So we'd have M L divided by T to the third. Right, so that's the overall unit. So a mass times a length to the time cubed. All right, next one. Next one we have the density rho times the velocity squared divided by the viscosity. And the density is just a mass per volume, so ml to the minus 3. Then the velocity is the length per time, and that all squared. And then for mu, that's one of the ones that we'll probably want to look up. All right, that'd be m L to the minus 1, T to the minus 1. All right, same thing as we did before. Let's draw our line here. So we have a mass, L cubed. Then we have an L here, but it's squared, so L squared. T minus 1, so that gets squared as well. That's everything we had up there. And then what else down here? We have an M as well. We have an L minus 1, so that goes up there, and a T minus 1 goes up there. So that would be ML to the third T, and down here we have ML to the third T squared, so the M's and the L's cancel. We're left with 1 over time. Let's see what else we have. We have the bulk modulus divided by a pressure. Well, this should come out to be dimensionless because our bulk modulus has the same units, right? It's given in pascals. So let's see if that works, right? If we look at the bulk modulus, it is given to us as m L to the minus 1, T to the minus 2. And, well, pressure is given to us as the same thing. Right, that already says has to be dimensionless, but just write it out like the same we did before. So we can say that'd be m L T squared m L T squared. Of course, that is just equal to 1. And then the last one we have is gamma times Q times L. Now, gamma is Newton per cubic meters. So in the end, that gives us mass L to the minus 2, time to the minus 2. The Q we already talked about, right? That'd be a volume per time. So it'd be L cubed T to the minus 1. And then L is just L. All right, what do we get? We get a mass. We get L squared T squared. Then we get L cubed and T and L. So that one means we get M L to the 4th divided by L squared T to the 3rd. And let's see, that simplifies to ML squared over T cubed. All right. So with that, we have figured out four different ratios or products and found their base MLT dimensions.